Thanks for the introduction. So today I'll be talking about interactive audio plugin development using the Wwise SDK. So it'll be mostly a gentle introduction to what is Wwise and how you can make plugins for it. And also there's going to be a bit of a section on how you can actually adapt an existing code base written with JUCE to also add Wwise as a target. So first, what do I mean by interactive? So I mean that the output, the sound output is actually modified by the user interaction. And by user, I don't mean the sound designer. I mean really the end user. So in the case of a video game, it would be the person who plays the video game. So that's pretty much what I mean. What is Wwise? So Wwise is a middleware mainly focused toward video games. So it has two parts, a part that is mostly targeted towards developers, which is the SDK part, and a part that is focused towards sound designers, which is called the offering. So here you have a screenshot of what the offering would look like. So it's basically a software sound designers use to integrate the sounds that they make in their DAWs into the games. So the developers use the SDK to expose some parts of the game through Wwise that the sound designer can then use to make interactive music. So Wwise also has plugins, much like typical DAWs do. But they're a bit different. They're actually composed of two plugins, not only a single one. So there's the plugin that is used within the offering that is used for editing. And there's another part that is used by the sound engine, which is used by the game. So that's actually code that is going to run inside of the game. Whereas everything that happens on the authoring side is actually offline. It's all at the editing time that it happens. Here you have a somewhat conventional and I'd say minimalistic composition of what a plugin would look like. So it has some source files for the sound engine plugin and some source files for the Wwise authoring plugin. And then it has some configuration files for building and publications, which we'll look at a bit later. So authoring plugins, once they're built, they basically consist of two artifacts, which is an XML descriptor file in which you would specify all the properties that you can modify in your plugin. And it outputs a DLL file that is used on Windows. So that's one part of it, and it actually links with the sound engine plugins. So it can actually provide real-time editing. And most of the stuff that you would actually expect to just works out of the box and is provided by Wwise itself. So if you make your own plugin, then things such as saving, reloading your plugin state, and undo redo are actually supported out of the box. So the plugin XML definition is pretty simple. So you have the definition for what type of plugin that you have. So in this case, we have an effect plugin, some really basic stuff about like what is your company ID, the plugin name. And this is where you're going to define all the properties that are going to be editable on the UI part. So here I have one property, which is called dummy, which is a float. And you can specify like the UI range and the default value, and we'll see in a bit. But basically, a UI gets auto-generated from that for you. So you don't have to make one, but if you want to make a custom one, then you can from that. And there's also one thing that is pretty important, is the audio engine property ID, which actually links this property between the authoring side of the plugin and the sound engine property ID. So as far as code goes, it's pretty simple. You just have to extend the default plugin implementation that's provided for you. And then you have some methods that you would have to implement yourself, like what happens on destroy. That's usually where you would have to delete yourself. because the plugin allocates itself also when the DLL is loaded. And every plugin is provided with what is called a plugin property set, which is the set of all the properties that you defined in your XML. So they get parsed when the plugin gets loaded, and it's provided to the plugin. So you can use that. And finally, one of the things that you would also have to implement for a minimum authoring side plugin is get bank parameters. So in Wwise, there's a thing called Soundbanks, which are used to communicate between the authoring part and the sound engine part, which is basically just like a packed, all the parameters packed into memory, and it's shipped directly to the sound engine. And then you have some boilerplate code, like I said before. The plugin actually allocate the memory for itself in the EK create plugin hook. And then you have to register your plugin when the DLL is attached. So that's basically what's necessary for the authoring part. For the sound engine part, so it consists basically of a static library, like I said before. But it can also have a shared version that could be used perhaps often we use it for game integrations like Unity, which requires actually a shared library. So there are many kinds of sound engine plugins that you can make, and that's actually the part of the code that is going to contain all of the DSP. So you can make an effect plugin, which is pretty self-descripting, mixer plugin, which also describes itself pretty well, a sync, which is pretty much an audio device, and a source, which is a sound generator. There are two types of effect plugin. They're in place and out of place. Out of place is used for time stretching, is when the output buffer is a different size than the input buffer. So as far as code goes, you basically extend, you implement the interface of the type of plugin that you want to use. And then you implement init term, some very basic stuff. There's a function that requires you to specify more information about your plugin. And then the core of what happens in execute, where you're given a buffer, and then you can do your processing. So that's the in-place version. So all the processing is done on the buffer that's given to that function. Yeah, and then some bootstrapping code to actually allocate your plugin. I'm not going to go too deep into the bootstrapping code because, as you'll see later, we have a plugin generator that does all of this for you. So like I said before, sound banks are used to communicate between the authoring plugin and the sound engine plugins. And when you're doing real-time editing inside of the authoring, the data is actually tunneled directly in memory. Whereas when you, in a typical game scenario, what would happen is the sound designer would do all of his things in Wwise and then export the sound banks into a binary format, and then that would get loaded by the sound engine later when the game runs. So one thing that is very important is that the authoring plugin and the sound engine plugins are two very different beasts. You can actually use two very different subset of C++ in each of them. So in the sound engine, since the code is going to run inside of a game, it's very important that there are no usage of new or exceptions, and that the allocators that are provided by the sound engine are actually used instead. Whereas it's not so important in the authoring side of the plugins, where you can use basically any feature of C++ that you would like. Handling memory allocation failure is very important. So it can happen very often in consoles. So that's something that needs to be handled further than just saying, oh, I'm out of memory, I'm not doing anything. So that's to be accounted for. And finally, you have to be very conscious of the footprint of your plugin in general. So also for the memory, but also for the CPU. So optimize whenever you can using SIMD which is used in pretty much all of the helper functions that we provide in the SDK. So one really key aspect of plugin development for Wwise that really differs from regular plugins is that there are many platforms to support, like a really huge amount of them. And that's mainly due to consoles. So with so many platforms to support, it gets really hard to have a build system in place that can actually ship on the platforms that you want. Granted, you don't have to support all of them. You could actually just support a couple of them for your needs if you're developing in-house. But if you intend to ship your plugins to the real world, then you would have to support many platforms. One way you can go around that limitation is you can make your plugin notching plugin only without the sound engine code. And so, well, it would have the sound engine code, but it wouldn't have a sound engine plugin per se. So it would actually, you can then pre-render the effects much like you could do in a DAW. So that's one way to avoid having to target so many platforms. And so with so many platforms, we actually had a really hard time in-house actually building out all of those platforms. And it was even worse for the people trying to make plugins for Wwise because they had no tools available for them to ease their life. So we decided to rewrite our build pipeline for plugins, and we added a plugin generator while we were at it. So the build pipeline is basically composed of 4 steps. The first one is basically a pre-build. So first you would generate your plugins from the plugin type that you would want. And then we use pre-make to create the solutions for the platforms that you want to target. So you can call pre-make for all of the platforms that we support. And then the build step is actually bootstrapped into the tool so that if you have the conventional development environment installed for that platform, it would just work. And then the packaging and bundling is when you want to ship a plugin, you would take the result of the build and package it into archives and have some metadata attached to it so that end users can actually install your plugin. So I'm going to do a live demo of all of that, and we'll see how that goes. Hopefully it goes well. So the tools are written in Python, and they're all command line tools. Oops. Yeah. So here I'm on the desktop. I have the latest version of Wwise installed right here. And the command line tool is called WP for Wwise plugins. So if we ask for help, we see that there are many commands that are supported, which basically are basically the ones I just talked about. So you have the new to create a new plugin, pre-make, package, build, etc. So let's create a new plugin. Just call new. Here I'm going to do an effect. It basically goes through the process of asking you all the questions required to generate your project. So in this case, I'll do in-place processing. I'll call this ADC. Yes. All right, so it asked for confirmation. Everything seems good. So it created the project where I was at. So I was on the desktop. It has basically the same file structure I was talking about before. It actually prefixed all of the files and the classes with the name of your plugin. So there's the sound engine part and the Wwise part with the XML. And it basically, it's a functional empty plugin. So you can use that to actually get started right away. So if I wanted, I could just pre-make that plugin, let's say for the offering. So perhaps I should show the help. That's good that I did that mistake. So actually you have to be in the directory of the plugin for this to work. Yeah. pre-make. You can see that I have a couple platforms available for me. So I'm on Windows currently, so I can pre-make for the offering and some versions of Windows for which I have the build tools installed. So let's do an offering plugin for now. So it'll generate the solutions for me, which are generated over here. And then if I want to build it, I basically do the same for the build step. I just give the target platform as parameter. Oh yeah, I need to specify the build config. So in this case, I'll just build release, because I have a release version of Wwise. And then from that point, one thing I forgot to mention is that here I'm just using WP, but it's actually an alias for the one that is inside of here. So the build scripts are shipped for every version of Wwise, which means that when you do the pre-make and build steps, all the build artifacts are actually located for that specific version of the SDK, which means that once you're done building, you can actually just open the version of Wwise for which you built. And then if I just create a new empty sound, you can see that the new effect that we created is actually over here. So it doesn't actually do anything. It has a dummy property that does nothing. But it generated a UI for you, and it would create a list of all the properties that you would have specified in the XML. So yeah, one advantage of outputting the build result directly in the folder where Wwise is installed is that you can very easily iterate over your plugin. You basically modify it, you rebuild it, you reload Wwise, and then you can keep doing that until you have a satisfying result. And then once you're done iterating and you want to ship that plugin, you would go and package each of the platform that you built, except I have to give it a version. I'm very happy I have good errors. All right. So as you see, it actually took all the build artifacts, like the DLL and the XML, and packaged it into an archive. So it took them directly from where they were built. So packaging here is actually a kind of a magic step. It actually knows where the files are going to be and tries to help you find them instead of having to do that process manually. And then once you're done packaging all your platforms, because you could potentially have like 10 of them. Like you could have Xbox, other regular Windows, Linux, Mac, whatever you want to support. All of these are going to be part of a bundled JSON file, which is generated by the generate bundle step. So as you see, there's a template for the bundle, which contains basically the image, the description, and metadata about your plugin that you can specify, and is going to be shown to users when they install. So that's basically the listing of the files for installation. And then the files that you need to ship to end users is just the JSON definition file and the archives for each platform. And they can basically be installed directly through, this is our installer. So you can just install any plugin from that in the plugins tab. So here I didn't have any image, so it's blank by default. But so going from beginning to end is actually a pretty simple process, at least compared to what it was before. So before you kind of had to know a bunch of things about specific formats for packaging, stuff like that. So now it's much more streamlined. All right, so that's as far as I'll go into how Wwise plugins work. I actually wanted to do a bit of an experiment when I started doing this talk, which was could I actually take an existing audio plugin that was made with JUCE and also target Wwise using the same code base, or mostly the same code base? So in that way, most people wouldn't have to rewrite their whole plugin just to add a new target, and they could more easily port their existing plugins. So, in this example, I'll mostly go through how it works for using the UI code. As far as the DSP code, not all JUCE DSP code can be reused inside of Wwise because some platforms have very limited C++ feature set, especially game consoles. But I'll just go into a bit of how you could actually still use the same code base if your DSP code was actually low level enough. So if you just did like if you had like a external code which processed the sample without actually using any fancy C++ features, then you could just call the same code from the Wwise execute function and the process block inside of JUCE. So that would be one way to do it. You could actually try also to make a bridge between the two audio buffer classes, but that may be a bit more touchy. So the plugin I will be porting today is a very convoluted volume control. And it's not even a good volume control. It's basically a linear gain from 0 to 1. But it's a good example of like a somewhat complex UI. At least we'll see that the UI is basically the same once ported. So how will we go about that? So basically, the audio processor editor class in JUCE can basically be reused almost as is. And the way you would do that is use multiple inheritance so that your authoring plugin actually extends our default implementation of a Wwise plugin, but is also an audio processor editor. And then you would have to do a bit of fiddling so that you actually initialize and deinitialize the UI at the proper places. So if I look at the header file, so basically just extend your audio processor. The exact same, you don't have to modify it. Basically keep it the same as it already is. And then you have to override the window proc so that you can create the editor and remove it when the plugin dialog is initialized and destroyed. So if you're familiar with Windows programming, you may have seen something like this. So here the messages are basically what you would expect from Win32 messages. And one thing I forgot to mention, so wait, I actually got it the other way around. So you have to extend the audio processor and have the editor composed inside of it. So you kind of act as if you were providing the DSP to JUCE, but you actually don't do anything in that case, since the DSP will be handled in the real Wwise plugin for the sound engine. And then you instantiate it, and yeah. One interesting thing is that once you do that, you're kind of stuck with two data models that you need to sync together. So JUCE have their audio parameters. And on the Wwise side, you have your property set. And they each kind of notify when the UI changes. And you need to keep both in sync. So the UI changes actually impact the Wwise properties. And then if something changed on the Wwise side, this is especially used for undo and redos, then you would also have to notify the UI that something has changed. And what you would expect from a schema like this is that you would end up having like infinite notification ping-pongs between each of them. But by default, it's actually not the case because neither framework actually notify when the property that you're trying to set is the same as it was. So it's pretty interesting that it works out of the box, but you can still actually specify that you don't want notifications when you set the value of a slider, for example. So yeah. So what I was talking about, the proxying part, actually I made a class that does this. And it's actually being instantiated and used inside this plugin. So here you can see that I added a smart pointer to that proxy. And then in the code, I basically just instantiate that proxy. I give it an array of all the controls that I have on the JUCE UI side, so I can actually have an idea of which property maps to which parameter index, so they can get mapped between Wwise and JUCE. And that's pretty much it. The rest is just event handling within that proxy class. I won't be giving like the full class here, but it's actually on my, I have a GitHub for it, for which I'll post a link at the end. So from there, one thing that actually was pretty frustrating is that once I had that working, every single time I would just close Wwise, it would basically shut down my plugin, but it would like leak everywhere. Like all of the JUCE leak detectors would fire, and I would get leak logs in Visual Studio. So to get around that, basically you have to know that since you're basically kind of acting as the host for that plugin, you kind of have to re-implement parts of what JUCE does for their host. So you have to initialize the graphical user interface for all the services and singletons. And then when the plugin gets destroyed, you have to shut down the graphical user interface. But even that didn't quite work, just shutting down the UI. I still had message leaks. And perhaps some people from JUCE can help me with that one. I found this hack deep inside of the JUCE code in some Mac clients, host code. So basically, I iterate like a couple times and try to run the dispatch loop for the message manager to avoid having message leaks between the time that like everything gets destroyed and unparented from the native window and the actual application gets destroyed. But in the end, it's not so important that you actually do graceful initialization and shutdown. Like you could just simply say that you don't really care about those scenarios because the application is actually returning all the memory to the operating system at that point. So that's pretty much not necessary. But the initialization and shutdown of the JUCE GUI are necessary if you don't want to fire up the leak detectors every single time. So where do we go from there? It actually works fairly well. It's the same UI as it was, as I previously showed, now running inside of Wwise. Obviously, it would be nice to also reuse the same DSP code. But one thing that would be very interesting would be to have this kind of thing actually provided by JUCE, having an official Wwise client for JUCE, so that all of the boilerplate for this kind of thing is actually done for you. And one other interesting thing would be to have VST plugin support inside of Wwise, so the other way around, which could be used for FX pre-rendering. Obviously, it could not be used inside of the games, but it's already pretty useful just to have some editing capabilities inside of the offering. So I think I am very early. I think I spoke a bit too fast. If you guys want, before the Q&A, I can actually go and show you the code. For the JUCE/Wwise plugin. So, so it's available on GitHub. So if you actually want to go and see the sources, it's not that complicated. One interesting thing is that building JUCE inside of our build pipeline was actually not that complicated. So I mentioned the pre-make plugin files. Well, actually, I mentioned that we use pre-make. So if you were making your own plugin and just wanted to add more files to the build step, you would add them in here, which is a file that is located at the root of every plugin that you make. So to compile JUCE, it was only a matter of basically including everything from JUCE except the client code, because obviously it's not going to be needed since we won't be able to target, well, we'll be the client in that case. So that's one thing to keep in mind. If you ever want to use JUCE in some context that is not like typical VST or AX or something that's supported by JUCE, and you just want to use the UI code and some of their library code, then make sure to exclude those, because to me it took me quite a while to figure out why I had so many compiler errors of missing defines and stuff like that, whereas in the end they were not needed since they were only required by the client code. And for the proxying part, so yeah, I can maybe show, so the JUCE plugin is basically a regular JUCE plugin with the processor and the editor, which doesn't have anything fancy. So the editor code basically just have all the sliders that I showed earlier, position. And then on the Wwise side of things, here is the proxy I was talking about. So it's an audio processor listener, which is built in JUCE, and already have some events, well, some hooks that are fired, like audio processor change, audio processor parameter change. So it's only a matter of checking what parameter change and setting the value in the property set for that parameter. So you really have to make sure that the parameters are in the same order in your Wwise plugin definition as they are in your JUCE plugin. But once you have that covered, it pretty much just works. So yeah, I guess I'll just end it a bit early. That's it.
Thank you very much. Has anyone got any questions?
Hi, thanks, enjoyed that. Last time I wrote a Wwise plugin, which is admittedly about 2 years ago now. Mm-hmm. I counted, just to add a single new parameter, I had to touch about 14 files. I had a crib list of things to go down, so very interested in the, what did you call it, the package authoring, WP script.
Yeah.
Do I understand that basically you just have to add a new parameter to the Wwise authoring XML, and then it then gets propagated to all the other files as needed?
So do you mean if modifying the XML actually modifies the UI that gets auto-generated?
Yeah, and all the other headers and everywhere else where that change will have to appear to build correctly.
No, sadly, that part doesn't get done automatically, so you still have to at least have some constant mapping to your property IDs.
Okay, so there's still a great deal of work to do just to add like a new RTPC.
Yeah, so the only part basically that you have to keep in sync is the audio engine ID that you specify in the XML and the one, perhaps a constant that you have on the sound engine side to keep track of which property is what.
Okay, that's not too bad.
Yeah, the rest is pretty much straightforward because on the authoring side, all the properties are queried by name, much like you would get in JUCE.
Okay, thanks.
Any further question?
Hi, this new script, is that only available in 2018 or is it available in earlier versions of Wwise as well?
Yeah, so it was shipped as part of 2018.1.3, so it's really recent. Sadly, it's not available for earlier versions, but my guess is that it would still, like if you copied the script files over to a previous SDK, it would probably work.
Okay, thanks.
Hi. You showed something about future VST support.
Mm-hmm.
What do you plan when?
There's no timeline for this. So it's just, we've been talking about it like internally for quite some time, like as a nice to have, but we don't really have a timeline for if we want to do it at all or when. But I think it would be a large benefit for people who just want to have some quick effects inside of the offering and pre-render it, instead of having to go back into their DAW and then export their sound and re-import it later.
Any other questions? Nope. Okay. Well, just big thank you again, and broad thanks.
Thank you.